So, hello, my name is Kristin. I'm going to talk to you a bit about legacy code. I'm going to start by a little introduction on myself. I started at CCP summer of 2005. It was like a few days before Cold War expansion. I was working with CCP Tom B and CCP Hammerhead, if you know those guys, doing balancing. Started in game design, worked there for 2 years, and then in the spring of 2007, I moved over to software. Where I've been more or less most of the time getting more and more responsibility until the fall of 2014 when I took over the technical director role of CCP Veritas, if you remember him. That wasn't that far ago. Here you can see the ceremonial handoff of the cowboy hat and coffee machine. And here you can see artistic representation of it. So, pro tip, if you work at CCP, never ever let anyone take a picture of you. Because this is pretty much what happens. Yeah, so like I said, I've been working at CCP for almost 10 years now. And I started thinking about what kind of have I specialized in my time here, and the only thing I could think of is that I know really, really old code. I know how to work in a really, really old code base. So my talk is about legacy code. And I started thinking about that, and we throw that term around a lot, but I think every programmer, everybody that works with any sort of legacy code has a different understanding and meaning about it. So I actually went ahead and Googled it, because that's what programmers do. So Wikipedia says legacy code is a source code that relates to no longer supported or manufactured operating system or other computer technology. So yeah, that seems to imply that it's somehow related to stuff that nobody knows anymore. Techopedia has pretty much the same definition. It's more about the source code. This is definitely true for a lot of the code at CCP. So while CCP has always been kind of in the habit of creating its own technology, even though there are commercially available products out there. But since then, people have developed them and they've moved on to other projects or left the company. So we have a lot of code that nobody involved in creating that code is around anymore. And Michael Feathers, I don't know if you know who Michael Feathers is. He wrote the Bible on this, working effectively with legacy code. It's a really, yeah, it's a really good. I've actually met him. I was quite starstruck. I bet that's how normal people feel when they meet Johnny Depp or someone. But yeah, he says legacy code is code without tests. In a lot of ways, I agree with that. I think code will become legacy code, well, or it's very, very likely to become legacy code if it doesn't have any tests. But I feel we're kind of stretching the idea of what legacy code is by calling it that. Although it's a very practical definition as well, because you can measure it, you can show this is legacy code because it's not covered by tests. So what do I think? I thought about having like a fancy definition of this, but I mean, in reality, what we're doing is we're basically talking about bad code that nobody knows how it works anymore. So it's basically a way of saying, dude, your code sucks. But I understand why. It's like we're sugarcoating it, right? We're saying like this code is bad, but I understand why it's bad. It changed over time. So let's talk a little bit about at least how I think that legacy code is created. So a lot of time I've heard programmers say that code seems to just go bad. If you leave it alone in the corner, it just goes bad. That's actually not the case. You actually have to make it bad. You have to create the legacy code like one step at a time. It's into it. It's the tiny fix that makes it a tiny bit worse. And one feature where you just, you passed in a Boolean argument to a function because that was easier at the time than actually structure your code properly. And most of those steps are completely reasonable. You can even see it in the check-in comments. I'm doing this horrible thing here, or this minor sin usually, because we're deploying this tomorrow, and I don't want to change all the code because that's going to increase risk in the short term. But as we all know, then the legacy code will eventually drown you. A really good example of this is the old crime mods. If you, yay. So does anyone remember the old crime mods, how it works, how the rules work? Yeah? Did anyone understand that? How they actually work? No. And it was a really good, because it's actually started out relatively simple. I mean, you were penalized for your own actions. Then some, exploits were found. A good example of that is when people figured out that you're not really penalized for helping somebody doing a bad thing. So what people did is they parked themselves around a Stargate. They had a bunch of their friends, shield repair them, and then they activated all the smart bomb. And a lot of people died. Everybody was angry. And so we fixed that problem under extreme time pressure, right? Because in this case, when you find an exploit, yes, you can penalize the offenders, but you plug the hole as soon as you can. So you do that a couple of times. A new exploit is found. You're a very creative bunch. So, and you do that over time, and all of a sudden, nobody wants to touch it. And that was the case of crime mods. Nobody really wanted to work on it. Nobody really wanted to do anything that touched on it. But you couldn't really avoid it, because if you're adding a feature and you could do something exploited, you had to kind of involve crime mods. So, yeah. So, and as I was implying before, is that the evidence was really obvious, and that's why I kind of like crime mods as this example. It was really obvious from the game rules themselves that this was happening, right? You had an exceptions, and if you'd ask somebody to explain it to you, they would inevitably go into like a history lesson of why this came into being, why this is logical. I mean, for example, why do we have a 2-minute timer when we jet this on a can? That makes no logical sense. But once upon a time, people dumped a bunch of cans in space, and you couldn't load up your client. Like I said, creative bunch. So as complex as those rules were for like the players, they were worse for the code, because we had to represent all of these complex rules in code. So basically what I wanted to say, it's not conclusion of the whole talk. It's just conclusion of how I think legacy code comes into being. It's the change. Like you change, when you change the code, it rots. And every change in requirement is a challenge to your design. And it doesn't really, it may sneak up on you. It doesn't have to be a requirement for somebody else. It can be a defect, a case you overlooked. All of that is a challenge to your design, and you have to take a step back and ask yourself: are the design choices I made originally, are they still valid? And when you have to change the design, you should never consider that a failure. I mean, design is a really bad word for what we do, because it's not how we construct software anymore. We don't design stuff and build it. We design, build. It's like an iterative process. It's more like growing a software. So yeah, refactor constantly, or your code will rot. So the reason I wanted to do legacy code at Fanfest, and why I think you might be interested, is that people have come up to, or asked on the forums about, how bad is the code and stuff like that. And I think people have sort of a misconception about how bad the code is. So you see, it's not all of it bad. It's not uniformly all bad. There are things that are really bad, and there are things that are pretty good. And for new things, we prefer working in something that's really good. Sorry. And this happens really kind of naturally with like the agile method that we we plan to have a feature, and the programmers put the cost in the thing, and then it just becomes a production value. Do we go for the really, really simple to implement feature, or the equally valued, really, really hard to implement? And it just naturally gravitates towards doing something that is new. And then when we change old code, we actually fix it, or at least make it better than it used to be. That's kind of one of the great rule is that at the very least leave a code in a better state than when you got to it. So industry, as you might have known, had gotten really bad. I remember I was adding reverse engineering to it. A task I estimated about half a sprint maybe. That took me like 3 sprints, I believe. Wildly overshot that, and it was pretty bad. And it wasn't really, it wasn't that it was jam-packed with features or anything. It was just, it had just been added to and added to and added to into a giant switch statement that was there. So we wanted to change it, and we could have shoveled it all into the old system. I forgot the animation on this slide. But we decided on a complete rewrite of the system. And that was really a thing where we saw an opportunity. We knew this code was bad. We knew game design wanted to do something with it, something better. So we kind of used the excuse, well, not excuse of features to actually radically improve our code. So and then comes the question, how do we actually know if we made anything better? Because it's weird. There isn't really a lot of like measurements that you can apply there. You kind of instinctively know through experience what is good code and what is bad code. So you can do that. From the good code, you would expect to be able to implement, well, value more than anything quicker than you do in the old code. So we could really add lines of code at it as a velocity, but I don't think that's a very good measurement, because the really, really old system that we were replacing actually didn't have a lot of development because it was bad. We could have story points finished, but that doesn't even make sense, because we'd have more story points in the more complex the system we're adding. So it's really value we're looking for. Total defects created, even though the legacy, the old code that we wanted to replace was really bad, it had been hammered together through years of testing by a lot of players and QA and stuff. So it more or less worked, but you just couldn't do anything with it without breaking it. So it's not the fact that it was broken at this point in time, it's just as soon as you start touching it, it breaks. So I decided on cyclomatic complexity, and this is not something that we actually look at very heavily at CCP, but I just wanted to give you an overview of what the difference between like old industry and new industry was. So I decided to look at cyclomatic complexity for this. And the nice bit about it, it's got very simple rules. I don't know if you know what cyclomatic complexity is. It's you basically count all the decision points of the program. So if statement is 1 point, the for loop is another point, and and else and all that is 1 point each. Yeah, and there are studies that have linked cyclomatic complexity to fewer defects, but there's also studies that have shown that it does not. So, but I will prove to you definitively that it works. Just wait for it. Total complexity of a software isn't really that relevant, because it's gonna increase by the size of the program. So lines of code, and yes, it probably has more defects, but it may not be more kind of broken. You're thinking about defect density more than total amount of defects, and complexity density, if that makes any sense. Yeah. So, and it's all important to know that this is a sensor. This is not a controller. You can't. If you start chasing this metric, if you start just trying to lower this by for the sake of lowering this, you may actually just make your code harder to read and not actually lower the complexity, the actual complexity of the code. So it's very important to not have this drive you, but it is interesting to watch this and compare good codes and bad code. And we have been running this on a site that actually broke down in January, I think, and nobody noticed. But we had been running it, and you can see like the top offenders of that, like the files with the most violations as such, most functions that go above some cyclomatic complexity threshold. And it pretty much coincides with what we already know, and we had, within EVE gameplay, talked about as bad code, right? So, but this is, as far as I know, this is the only reliable metric on code quality. But it's not really so practical. You can't really put a mic next to programmers and listen to them swear and start. Well, we could with PrismX. And start listening to them swear and start correlating that with what file they're actually working on. But sometimes those profanities actually slip into the code, and I thought that was really interesting. So I started thinking, okay, so maybe, but it's not that much profanity. It's not really practical because we can have a really, really long bad code that doesn't have any profanities. But maybe if I can establish some kind of relation between complexity and profanities, then you can allow me to convince you that complexity actually matters. So I made this graph, and that's actually not a very good graph. This is all like, on the x-axis, we have the, here. This is complexity per line, and on the y-axis, we have amount of profanities. And I just fed a list into it, and it actually doesn't prove my point, because when I drew the trend line, it actually went down a bit. But I think that's because I'm excluding all the files that don't have profanity. So what I thought about instead of looking at that is, for a certain profanity per line band, what is the chance of that file having a complexity? And then I got this graph. So if for a file that has a complexity per line somewhere between 3 and 4, 0.3 and 0.4, we actually have 11.3% chance of it having a profanity in it, which I thought was really, really awesome, and I'll be working on my thesis on that. So I mentioned two big projects, like refactoring projects that we've done recently. Well, one of them was 2012, and the other this summer, last summer, sorry. Has summer started? We had sun until it was briefly blocked out by this moon. Right, so as you can see, complexity actually went up, so it might seem that. But like I said, total complexity doesn't really matter in this case, because new crime watch has a lot more features, lots more bells and whistles, including like the combat timers and stuff like that. Same goes for industry, but the industry stuff also has some like static data manipulation that wasn't part of the industry system in the old code. Also, what I forgot when I was doing this is that both those systems now have tests, so that is also in the complexity. You can see it here that the lines of code actually increased as well, and that kind of coincides with the whole, they now have more logic and no more features, right? But total complexity per line of code actually went down by quite a significant amount. And the average file complexity went down by a lot. And I think I can probably, I'll get back to that, because I only recently, like today, discovered, had a theory about why why that is the case, or why we have old files with many thousands lines of code. Or basically, why were we so afraid of creating new files? The average function complexity, and that's, I think, is one of the most relevant metric in there, because it kind of speaks about how much logic each unit. It's basically how much can you process at the same time. How big a world do you have to build up in your head to understand it? And I think that the lower you have this, although I think once you have you're down to these values, it doesn't really matter that much. But you can see, from average complexity of 7.19 to 2.5, that's, it's gonna be hard to rationalize that the old code is better, right? So basically, the code is better. I don't know if we actually talk a lot about this externally, but within CCP, we always complain about our code. Maybe that's just the nature of programmers in general. I don't know. Is it? Are you programmers? Do you complain about your code? Yes. I thought we were really unique. What are you talking about? All our code is out there. Yeah, but it's not really as good as we like it to be. And this is, I don't know if you can read this. It says, here be dragons. If you decide to try and sell this item appearing for items in post structures, be careful, you aren't the first. Now, there's a funny story about that. A programmer, CCP master plan, was fixing that issue. And once he had fixed it, it broke something else. And I may be lying about this, but let's not ruin a good story about with the truth. So when he fixed that, he broke something else. So he went ahead and he fixed that, and that broke something else. So he started looking at the code, and he didn't see a good way of making it work. So he reverted the whole thing back to the original state. However, he started looking at the code history, and he could see the exact same 3 check-ins by another programmer going through this exact same. Decided to write up this little warning for someone. And this is actually from a good example file. It's called the menuservice.py, and it frequently comes up in our talks, all the time. And it will come up after this Fanfest because some numbers I dug up are scary. It's the service that gives you right-click menus. It's mostly a collection of unrelated things. It doesn't really have to be all in the same file, but it's there. And that's not maybe so, well, it's bad, but it's not so horrible. But Celestial menu is by far the worst offender. That's the menu. That's what creates the menu when you right-click anything in space. And it's thousands. It's more than 1,000 lines. I think it's like 1,300 lines. It takes in 7 arguments, where one of them is data. And because it's Python, it's not going to be like data that has these attributes. It's going to be data that is, whatever. And it's plus 600 in cyclomatic complexity. And to compare that with the improved crime watch and industry systems were like 2.5 average. This is 600. You can actually, I'm gonna scroll back into, because that image, you can see all the red thing here. Those are ants. Yeah, debug that. Yeah. And we need to change this frequently, because whenever we make a new feature, even though we try not to have everything in right-click menus anymore, we still need to put something in the right-click menus, even though it's not the primary way of accessing stuff. Yeah. So it's to sum that up, it's the code is not as bad as we tell everybody it is. it's certainly there are areas that improve, but it's important to celebrate your little successes. I wanted to talk about two things that I think have been our major contributors in us kind of turning. And I think it's important. What I want you to walk out here with is the fact that yes, CCP has created amazing amount of legacy code, but it's getting better. It's better now than it was last year, and it's better than it was the year before. So code reviews are awesome. Do you review code? Right? Everybody does that. Again, I know there was a time at CCP when we didn't review code, but I can hardly remember that anymore. So it's great. The sooner you can find the defect, the better, the less expensive fixing that defect is. If it goes all the way out to CC, to you guys, that's an expensive fix. But if one of the programmers just says there's a bug in your code, that's a lot cheaper. It's also a fantastic way of distributing knowledge, and that's something that we didn't really have when I started at CCP or started programming. There was I was basically handed a feature and in Dogma of all places and told go nuts. Yeah, so it's an excellent way of distributing knowledge. It's a great way for programmers to talk about code in practical terms, but yet in kind of best practices and stuff like that. It's a great way for junior programmers to see how senior programmers do it and so on. You benefit a bit from the ego effect because if you know somebody is going to be looking at your code, you're not going to send crap there if you care at all about like public perception. So, yeah. But the problem is you can't have like this negative feedback. You don't want people to not want to send stuff to code review because that other guy is going to say really mean things to me if I do. Same goes for people, sending out to code review. They can't be like aggressive in throwing out any critique on their code. And it's important to realize that people are criticizing the code, not the reviewer or the reviewee. Right. The second bit is test your code, and it talks about automated testing. So why don't we, like I said, change causes code to rot, and why don't we actually, and we all know that, instinctively we all know that we know the right things to do, but why don't we do it? We do it because of risk. If we have large change, it's going to increase risk, and if we need to get the fix out sooner, then we are a lot less likely to actually do the proper change that needs to be done. And it's important to realize that there isn't, and part of it is I actually changed this line, but it had, so the severity of the defect you create is not linked to the severity of the defect you're fixing. For example, in that menu service example, then you can be changing something as insignificant as not showing sell this item to items that you're selling in a pause or you have in a pause. But you may break all items, all right-click items in space. So the fallout can be quite significantly worse than what you were trying to fix. So, yeah. And the test, and this I think is probably the greatest thing about automated testing. Once you know them, they remove the fear of deploying stuff. So I've done some crazy refactoring tasks a few days before I'm checking it out because I trusted all the tests to actually find all the bugs. Well, all the cases that I knew about. But writing tests is hard. We started doing this a few years ago, but it's a really, really hard thing, and people often talk about why don't programmers, write tests for the code. And just getting the code to run in a test framework can be really hard. especially if the code wasn't actually designed to be tested. And also, if you haven't done it before, it's a new skill, so you're probably gonna be really, really bad at it. It's unrealistic to expect to write good tests the first time you do it. So the first tests are probably going to be bad and fragile. So it's very easy to get demotivated and not do it. But I would definitely advise for writing tests. So in Eve we had a rather big blocker. We called it nasty, and it was a custom importer. Yay. Who, when you ask anyone, I want to write my own importer, people will say, no, you do not want to do that. And it did a lot of other stuff. It allowed you to reload the code, and this was before that feature was introduced to Python. There was no file reloading automatically. And that is actually, if you don't write tests for your code and you just rely on manual testing to create, this actually boosts productivity by a massive amount, not having to take everything down and put it back up again. So we had really shallow namespaces, but hierarchical file structure, and you could do circular imports. I didn't really see that as a good thing, right? You clearly have some deeper issues if you have circular imports, and you shouldn't just have power through them. Yeah, but this actually may seem like a crazy idea to actually have done this, but the fact of the matter is that none of that stuff existed in Python when we started using Python. We started in Python 1.5.2 or something like that, and there wasn't, there weren't packages, there weren't anything. It was just, you just had to manually create it, but we neglected to actually confirm with the Python way afterwards, and that was, I think, the biggest mistake. So how it works is it basically loop over the file system and look for this index.txt file, and that when I was talking about us being afraid to make files back in the day, I think that is actually the cause of that. It may seem insignificant, but having to put the file name into an index.txt file, I think just, I'll just put it here next to the other code. And then we injected the classes and function based on an export stick. And the export stick, I wanted to give you a quick example. So it would basically loop over that, look for the export thing, and dump the function foo here into the util.foo namespace, which isn't capitalized, and that is intentional. That's what they do. Good luck finding where this is defined. Yeah. So that's basically how it works. I have a point with this. We'll get to it. So Python works kind of differently. It pretty much follows the file structure. If the path is, has the root, foo, bar, bars, you just import it with that. That's pretty simple. So, yeah, and you have to sprinkle these dunder init files all over the place. So nasty code, as you might imagine, doesn't really work. And if you were to import the code we created within nasty into vanilla Python, it would just not work. So it only worked with exifile interpreter, and it was really, really slow running that. It was very, very fragile as well, and it basically sucked. It was pretty bad. So we removed it. It was, and in the end, it wasn't that it was like unbelievably amount of work. I may be, exaggerating that it wasn't really difficult. It just wasn't really difficult for me. So we added a bunch of those dunder init files in it. We created nasty space folders, and that was more of like a crutch to maintain the old nasty namespaces, because we didn't want to go through all the code. We had the kind of limited time to get this working. And the nasty base folder are basically they're basically files in a special directory that we have a bunch of imports, and then we fixed all the circular importing that to actually make it work. Okay, so there was a bit more to it, but yeah, that was the gist of it. So testing is still really, really hard because even though we've removed this huge nasty blocker, we still have a bunch of code that was not designed to be tested. We also have a lot of magical built-ins all over the place. But more and more programmers are writing tests now. This is not something that we enforce, as in. I don't think you can really enforce this on people because I think in the end you'll just end up with badly written tests. So now around 50% of our new code has tests. I haven't really, well, I mean it's not fantastic, right? We want more than that, but it's not insignificant either. So a chunk of our code is actually covered by tests. Now I just have to find if that number is actually getting higher. So now there's a conclusion, right? So basically rules to survive in a legacy code is follow the Boy Scout rule. Always leave the code in a better state than when you got to it. Just even if you just fix something else that is slightly related to it, just make sure. Avoid kind of the broken window syndrome where you look at the code and says, well, this is already horrible, so nobody cares if I add a tiny bit more logic here. Write tests for your code. I think you really. Does everybody write tests for the code? No? Yeah, we try. It's like I said, I'm not surprised that not more people do it, but I really think you kind of need to, you kind of have to just believe it almost like a dogma that it works until you realize that it does work. It may seem like a weird thing to say, but I'd say at least if you try it and you realize it sucks, see if it sucks because testing sucks, or see if it sucks because you wrote bad tests. Do code reviews; those are fantastic, and of course, have the culture of not being aggressive. And, yeah. Give honest estimations, and this is probably so. I talked about stuff we do, but that is all meaningless unless we have the bandwidth to actually do that, unless we have the bandwidth to know how to do test-driven development and write unit tests and all that stuff. And if we don't have bandwidth to actually do that, we'll never learn it and we'll never get better. Same goes for code reviews. If you write people so hard that they don't think they have time to review other people's code, that's like a massive waste to me. And then finally, celebrate small victories. We've often been very bad with that. We complain a lot about our good code, but we never really talk about the good stuff that we've done. For example, both the industry and crime watch went unnoticed by a large part of the developers. So I hope some of them are here and can see you do a good job. So yeah, that's pretty much all I have to say on that. I think we have like 5-10 minutes for questions. Yes?
So we have a check-in requirement where there has to be a test for every feature.
Right.
And we're moving to, the test has to be written by a different developer.
Okay, so they're like acceptance tests or?
Because one thing about writing tests when you start is you're looking at your own code, and your code's perfect.
Yep.
And nothing can go wrong in your code. So I'll just write some tests, but it doesn't do anything.
Yep.
But when you have other developers who is writing the test for your code, first of all, you have the knowledge sharing. So
yep.
They start to understand what you just did. But also they're going to be meaner than you.
Right, yeah, I don't know. Repeat the questions, right. This gentleman here says that they have another person writing the test than actually writes the code, because the programmer that writes the code isn't going to be as kind of critical of his own work because he already thinks it works, right? I'm paraphrasing, but that's more, yeah. I'm not necessarily sure I agree. I think we can be quite aggressive towards it. And I write tests for what I think might fail. I also do test-driven development. If you know what that works, then it becomes more of a design part of it. They talk about tests as like a side product of actually of designing the code. I think that's a pretty awesome side product to have. So yeah, I don't know. I kind of disagree. I think you should write your own tests. And one important bit is that if you write tests, then you got the first step right. You can write another test because you can run that code in a test framework, and that to me is also a huge step. So if something comes up and you can't prove code correct anyway, so something even with you write all the tests you can think of. You can still break something, but at least you can write tests for that then as well. So, yeah.
What's CCP's stance on Python right now? Do you guys see yourself moving to something like Python 3.4 in the future? That's a big question, I know.
Yeah. Maybe it's not on the the immediate stuff. We looked at Python 3 some time ago, and I think the general consensus was that it actually performed worse than Python. We are also on our own special snowflake of stackless Python, which is already a special snowflake of Python. So it's not in the immediate future, but it's definitely something we should be looking into, getting kind of more into like the mainline versions of Python.
Was that when you looked at Python 3.4? Was that say like in the earlier versions of 3?
Yes, that was definitely in the earlier versions of Python. Sorry, wanted to repeat the question.
The question was.
Oh, you had. Or sorry.
Yeah. Why don't you repeat it?
Yeah. You over there.
Just sorry, since we're on the topic about legacy code, this may be a loaded question, but we all, for those of us who are keen, we all know there's issues with dogma. What is your thinking on how to handle that and how to move on from it to remove, let's face it, the massive bottleneck that we all experience on a day-to-day basis?
I'm sorry, can you repeat?
Not loaded at all.
No, I'm sorry.
Dogma, how do we move on?
Well, I mean, there is talk about dogma rewrite on Saturday, right? Yeah. So I didn't specifically talk about that any here because they already have discussions on that.
Okay, I must have missed that off the schedule, sorry.
Yeah, that's fine, Sorry? 4 p.m. Saturday. Yeah. So. Okay. Oh, sorry.
Hello. This sounded a lot like continuously improving your code. By whatever you touch something, you write tests for it and so on. Do you have an estimation of when you have reached your complete code base? How long will it take?
When I have an estimation on what? I'm sorry.
How long it will take that you have covered your whole code base, that everything is improved and doesn't feel like legacy anymore?
Oh, no, I don't have like a projection. That would actually be interesting to have. 2050, yes. But I mean, it's a journey more than a destination. So, and that is something that you just have to realize when you're working in a legacy code is that you can't fix everything straight away. So you have to just recognize there are some things that are broken, and you have to recognize there are something that you did well and celebrate that.
I heard a very interesting question about the state of the legacy code and the problems that it's sort of causing for Crest. Is that something that's going to be addressed in the near future, or?
For Crest, I think you'd probably...
For example, I've heard that one of the problems that have been with Crest was that when you basically logged in through Crest to do changes to orders or whatever it was, your ship also logged into the game at the same time, because the client was only... or the server was only adapted to see it through as a client login, and that's all legacy dependencies on that sort of thing.
And it's actually a really kind of a difficult thing, because the underlying assumption, like from the beginning, is that you only have one session, right? And we have all over the code, we have just assumed that. So it's not a matter of going in one place and fixing it. It's all over the place. I think, yeah, we're definitely going to look into allowing you to crash stuff, because it's a big blocker for a huge win, and we will get to it and soon, hopefully.
Are you able to determine, even going back 6 months, whether you wrote something, or can you tell if it was master plan? Even though you have the same way of writing things, and are you able to determine who wrote something just looking at?
Just looking at the signature of the code?
Yeah.
No, but I read something. I haven't tried that, but I read something that they ran this thing. I think there's an open source project on it. I can't remember. I just remember seeing something about it, that they could pick out individual developers on a big open source project by just looking at the code. Yeah, I should Google it. It was very interesting. Yep, and nothing more? Okay, then I thank you for your time.